Hi all of you. So today I'm going to discuss with you a question which was posted by one of the students, a very doubtful, a very good question, which is based on recent observations, which is not there, which you can't find in your textbooks mostly. Okay, and I think that's a good question to discuss in our doubt clearing sessions. Okay, so the question is, which of the following is associated with defective apoptosis? Okay, which of the following is associated with defective disease? Okay, they're asking with defective apoptosis and increased cell survival. I'll come to the question. Okay, once I explain it, you'll understand it better. The options are neurodegenerative, stroke, autoimmune, and myocardial infarctions. And the answer, if you have gone through your previous questions, you could see that its correct answer is autoimmune. Now, the problem is, people doesn't know how does it connect. How does apoptosis connects with autoimmune disease? We studied apoptosis, we studied autoimmune disease in detail. We've discussed apoptosis in detail in general pathology, isn't it? We've also discussed autoimmune disease in detail in different areas, including microbiology, oral pathology, general medicine, and so on. So, autoimmune means self-destruction, disorders where antibodies are formed in the body against our own connective tissue components which destroys it. Okay, so we've discussed different examples. One example is rheumatoid arthritis. Okay, so let us discuss this connection between the two, apoptosis. So if you have any doubt about apoptosis, go to the lectures on apoptosis and understand it. If you have doubtful, because I'm not discussing it again. What is basically apoptosis? Planned cell death, isn't it? The killing the cells in a planned way. It's a physiological, it's a normal mechanism. It's not an abnormal thing. It's a normal mechanism where we've got in our body a normal mechanism which kills those cells which is not required or is already aged. Okay, that is known as apoptosis. Okay, so how is this connected? That is my main purpose of discussion here. So, T cells are immune cells. T lymphocytes are immune cells, is there in immunity. There is a role of T cells in immunity. What happens in some diseases is that this T cells, on surface of T cells, again we have studied on the surface of T cells, there are cell surface receptors. Okay, and some proteins. One of such protein is CD95. So there are different CDs, okay, of which one protein is CD95. So this CD95 get mutated in some diseases. Okay, due to various pathophysiological mechanisms. So just understand there is a mutation, okay. And the mutation, you can be different agents causing the mutations. I'm not going into depth of it. So mutation in CD95 proteins of T cells. So this is seen in some conditions which can lead to autoimmune disease. For example, rheumatic fever in rheumatoid arthritis. So in rheumatic fever, it's a predisposing condition for rheumatoid arthritis. Okay, so in that case, this in rheumatic fever, for example, this protein gets mutated. Okay, this protein gets mutated, and as a result, the T cells are not cleared. Normally, what happens? You have got a T cell which is normally what? Cleared, or which is undergoes apoptosis normally. But as a result of this mutation here, what has happened? There is no clearance. There is no apoptosis. Okay, there is defective clearance. So that is defective apoptosis. This is defective clearance means defective apoptosis, and as a result the T cell survives for long because there is no apoptosis, there is no planned cell killing. So the prolonged survival of T cells. Now let us come to the question. What is the question? Which of the following is associated with defective apoptosis with increased cell survival? So what has happened here? The cell didn't undergo apoptosis because of this particular mutation. The cell was not recognized. The T cell was not recognized by the apoptotic mechanism. Again, we have discussed the mechanism in the various lectures. So this, as a result of this, there was a defective apoptosis, and as a result the cell is surviving, still there. Now if T cell survives for a longer period, what it can do? It can stimulate B cells. Again, we studied it in immunity chapter. T cell stimulates B cells to produce autoantibodies, or I would say antibodies in general. B cells get converted to plasma cells and antibodies are produced. Now see, here there is prolonged survival of T cells. What it can do? It can stimulate B cells producing antibodies. As a result, you get autoimmune disease. So this is the connection between defective apoptosis, prolonged cell survival, and autoimmune disease. Understood. So it's very important to understand this for this particular question, because I've discussed this specifically because we know what apoptosis is, what autoimmune disease is, but the connection has been recently recognized. Earlier it was not known. So there's a connection between apoptosis or defective apoptosis of T cells, to be specific, as a result causing autoimmune diseases, various autoimmune diseases. So hope you have understood it. Okay, just we'll make it very short this time because a little conceptual understanding was required. So that's it for this doubt clearance session. Thank you so much. See you in the next class. Bye.